Hello, our team is EHAC. That stands for Electric Heating and Cooling. My name is Tiancum Bush, and my team members here are Keaton Shannon and Bradley Hoffman. Next slide.
The objective of our project was to analyze the HVAC system of a home and just kind of think about how we can reduce the local emissions released due to those systems. So we didn't actually build anything for this project. It's purely a research-based project. Next slide. So we focused on single-family dwellings, and we explored what change we could make and how that would affect both the environmental aspect of things and if that would be financially viable. We also took a look at what changes would need to be made to transmission and distribution systems to allow for a large-scale switchover. Next slide. We had two main models, an existing home conversion and a new home that would be built with the new system in mind. You can see in the bottom left for the existing home and the bottom right for the new home. Next slide. Our decision for the best option for an existing home would be to replace the AC unit with a heat pump and just leave the current gas furnace. The heat pump would work the same way an AC unit would, but with the addition of taking over the lighter heating loads from the gas furnace, so that the gas furnace would still kick in when the temperatures get really cold, but the heat pump would take a lot of that responsibility. Next slide. With a new construction scenario, this would look pretty much exactly the same, except it would all be built into one system as a dual fuel heat pump that uses natural gas and also works as a heat pump. Next slide. We did an analysis of the electricity and natural gas that these systems use, and there's never a moment where we're using more natural gas or electricity than we previously used. So we decided that no changes needed to be made to the transmission and distribution systems. Next slide.
After running our BOPT models, we came up with a few numbers that summarize the kilowatt hours or energy needed in order to run each of these systems. So we ran a standard air conditioner with a gas furnace, a pure heat pump, which, as explained, won't work in temperatures lower than 25 degrees. So our final solution was a dual fuel heat pump. And you can see in all three of these scenarios, the cost that it turned out to be for 1 year to run these systems. That shows that the dual fuel heat pump is more expensive than a standard option, and that is due to the price of electricity when compared to the price of gas. Next slide. If you take that and project it over 30 years, these are the costs you end up seeing. These include installation costs, maintenance costs, and operation costs. In both cases, a standard HVAC solution is cheaper, but the dual fuel is better for the environment. Next slide.
We did an hourly analysis of temperatures in the last year to determine how many hours would need to use the natural gas method instead of the fully electric heat pump. And we determined that our methods could reduce natural gas use by 76.48%. We also conclude that this can correlate to a 76% decrease in local pollutants that may become trapped due to an inversion hitting the area, and this can benefit the overall health of the area. Then we did an analysis of the carbon emissions, and we determined that in a best case scenario, we would decrease the carbon emissions by 35% about, and in a worst case scenario, we would decrease carbon emissions by about 17%. Now, of course, we have a lot more detailed findings that we would love to go in with you. If you have any questions, please stop by on May 4th from 6 to 8, and we'll be happy to answer your questions. Thank you.